You know, Ed, as the father of expert systems, the person who conceived of and designed the first system that could function at a level of competency, and I suppose we should mention it's a program called Dendril, I believe, which was able to engage in spectrographic analysis at the level of a university-trained chemist. Were you surprised when you surveyed the field of industry and discovered the ways in which expert systems have now been employed?
That's an interesting question. When we developed the first expert systems at Stanford in chemistry and in medicine and throughout the 70s in engineering as well, from that I induced a set of ideas that I thought, a set of gains I thought would be present in the use of expert systems when they migrated out of the laboratory into industrial use. I used to give executive seminars on that subject, and recently I've gone back to look at what are the real gains that companies have seen versus what did I predict in the early 80s. And I think there were two really big surprises there. One was the immense productivity gain that we saw when humans, professionals and semi-professionals, were assisted by an expert system. We saw almost always gains of a factor of 10 or a factor of 20 or a factor of 50, sometimes even 100 or more. Now, engineers have a word that they use to characterize changes that they see in something by a factor of 10, and that is the term revolutionary. For example, the difference between walking and driving is a factor of 10, or 1 order of magnitude, as scientists say. And that factor of 10 really revolutionized the way we live. It created the suburbs, for example. The difference between driving and jet planes is just 1 factor of 10. And here we saw expert systems speeding up the work of human professionals by at least a factor of 10 everywhere they were used.
Now let's distinguish for our viewers the difference between an expert system and, say, conventional data processing.
Well, the difference really goes back to the difference between the programs which are called artificial intelligence programs and the programs which are conventional programs. Conventional programs, we know from the, as far back as the mid-1930s, from the work of Alan Turing, that the machines we now call computers are universal, extremely general symbol manipulators. But in the first era of computation, the only tasks they were put to were essentially trivial tasks, manipulating those symbols which we call numbers for number calculating, or filing and retrieving of data. Those are really simple applications of what a computer can really do. Now, we know that computers can conduct reasoning tasks. They can pursue lines of reasoning leading to the discovery of solutions to problems, the formation of hypotheses, the formation of concepts, and so on. Expert systems are programs that pursue lines of reasoning aimed at the solution of certain kinds of problems in narrow specialty areas normally regarded as the province of human professionals or highly skilled experts or technicians. Those expert systems perform at very high levels of competence in those narrow, specialized expert tasks.
For example, I believe you worked on a program called Mycin, which was involved in diagnosing and prescribing drugs for cancer patients, if I'm correct.
Well, the Mycin program was a program for diagnosing infections of the blood and meningitis infections. The Oncosin program, which is a follow-on by Professor Shortliff and his group in our Knowledge Systems Laboratory at Stanford, assists doctors in prescribing chemotherapy for cancer. That's a difficult task that doctors sometimes need assistance on, especially if you're not yourself an expert at that task. The program serves the role as a consultant in assisting non-experts in doing cancer chemotherapy prescription.
So that would be a typical example of an expert system.
Well, typical examples abound in industry, not particularly in medicine, although pioneering work in this field was done in medicine. But in industry, you'd find typical expert systems doing troubleshooting for machinery, or assisting with the design of machinery, or making complex decisions about things like investment portfolios, assisting manufacturing engineers in configuring parts during manufacturing, assisting salespeople in helping customers choose the right kinds of products, even assisting, for example, assisting government agencies in helping citizens to figure out where they stand vis-a-vis the complexity of bureaucratic rules that they're faced with.
Now, let me shift to you for a moment, Penny. You are a knowledge engineer. Your task, as I understand it, is to work with a human expert who has, over their lifetime, acquired extensive knowledge. And today we find in the corporate world many experts who are on the verge of retiring, and their knowledge may not be passed on necessarily to younger people. There may not be younger people coming up in certain fields. I know one case was an engineer who monitored a blast furnace, and there just aren't too many of these people coming into industry and other fields like this. So you work with individuals like this and get them to describe to you how they do what they do in a way that enables you to take that information, that knowledge, the rules of thumb that they have, and capture it in a computer system. What's that like? What's the process like on a personal level?
Well, one of the simpler analogy might be what you're doing now. You're interviewing us to find out what we're doing so that you can communicate it to your audience. Well, in the case of a knowledge engineer, they're interviewing a specialist so that the knowledge engineer gets some understanding of what the expert is doing, enough so that she or he can communicate it to a computer to do exactly that. So in a sense, it's a much more in-depth interview. And there are two parts that we want to find out. One is the pieces of knowledge that the person is using. For example, if you're an automobile diagnostic person that I'm interviewing, then I'd like to know, what does he know about the automobile? What does he know about carburetors, for example, if there's a difficulty with carburetors? The other thing I want to find out is how he is reasoning. That is to say, what logical process is he going through to use the pieces of knowledge he has? And combining the pieces of knowledge you get from the expert and the way he uses those pieces of knowledge, we can construct a program called Expert System.
You know, I'm reminded of the story of Socrates, the philosopher who went in ancient Athens and asked all of these professionals to tell him how they did what they did. And although they seemed to be able to train apprentices and so on, they could never answer the question to Socrates' satisfaction.
Well, that's quite true with knowledge engineering also, because if you ask a person how do you do something, they usually give you a textbook answer, something you can find in a textbook. But experts really know a lot more than that. They have a lot of experience. They've seen the same situation or similar situations before. So the best way I found is to have them go through an example and sort of think aloud. And of course, thinking aloud isn't everything that's going on, so I have to watch their eyes if they're looking at certain data. And if they're saying something else about some other data, then I know that something else is going on beside what he is saying. So you have to be very, very careful to try to understand exactly what the expert is doing.
So there are many subtle skills involved in being a knowledge engineer.
Yes, perhaps.
And yet, am I not correct in my understanding that there are actually now expert systems that perform the function of a knowledge engineer?
Yes, these are called expert system shells. They contain what I told you before about the reasoning process. We know that there are few ways to reason that people tend to use most often. So those methodologies are already implemented as software. And
you can buy many of them right off the shelf these days, can't you?
Quite cheaply for PCs these days. And also it contains different ways to represent knowledge, factual knowledge, rules of thumb that an expert might have for making decisions.
Mm-hmm.
And given that shell, sometimes these days experts can even write down the kind of rules he uses to make decisions.
But don't you find that with some experts that they'll describe to you, as you say, a textbook explanation of,
Yes.
of what they do, and then you go and watch them, and when they're performing maybe at their very best, they're not doing at all what they told you they do.
That's right, but I think they use same techniques that I do, which is using examples. They might say, well, here's the situation, and what do I do in this case? And then write down the rules for that case. So you do it case by case. Or sometimes they look through engineering manuals to start out with the kind of knowledge he uses, which is written down in engineering manuals. Because in some sense, he's really distilled or memorized the engineering manuals.
Well, I have to assume that as a knowledge engineer, you've probably worked with professionals from a number of different disciplines,
Yes.
and yet you yourself, in the process of learning their knowledge and learning their rules, haven't become qualified to the level that they are in their own discipline.
No, I can only mimic. I find one of the most fascinating thing about being a knowledge engineer is that in fact you get to learn to some extent, very shallowly, but what the experts know. And so that brings up a very good point, that if I can mimic an expert, I can know only in a very shallow sense what he does. And in the current expert systems, they are also very shallow in the sense of knowing very narrow area of expertise and for specific situations. They cannot, for example, reason from first principle about the field. It can only perform to a degree of what it's been told.
I see.
in the
The
system.
reasoning from the first principle, I suppose, is what Socrates was trying to get at with people and failed to do. Let me turn to you, though, Ed, and perhaps we can get a context of how expert systems fit into the larger field of artificial intelligence. They seem to be the most productive, the most used in the workplace of some of the other areas of artificial intelligence.
Well, the expert systems work flows out of the mainstream of AI from its birth, which was the study of problems and problem solving. How does problem solving take place? What is the nature of a solution? What is the nature of search for a solution? Expert systems came straight out of that. It came out of that, however, in a peculiar era, the era in which the artificial intelligence field was focused on a particular view of intelligence, the view called generality. The view that says that the intelligent mechanism is one that can turn its attention from one subject to another. The same machinery can solve this problem and that problem and another problem by various methods, including mathematical theorem proving methods. At that point, this program you mentioned before, the Dendral program, was born. And it was born with another view that said, actually a view that emerged from trying to get it to solve problems at world-class levels of behavior, like PhD chemists. And that was that knowledge was critical to how well it performed, not reasoning. So everything that AI knew about reasoning flowed into the Dendral project, but what came out was a view that said that knowledge is power. It was called the knowledge is power hypothesis, now sometimes called the knowledge principle, that the main ingredient in being intelligent is not how clever you are at reasoning, but how much knowledge you have about a particular area. Just to give you one example, our laboratory sits about halfway between the Stanford Mathematics Department and the Stanford Medical School. If someone got sick in our laboratory, we would rush that person over to the medical school because we'd be sure to find people knowledgeable about medicine. We would not rush that person over to the math department wherein resides some of the best reasoners on the campus, because reasoning won't help. It's what you know that counts. Now, the question is, how broadly do machines know anything? The answer is, machines know very little today. However, we can cause them to know a great deal about narrow little things.
Because normally we think about machines not as having knowledge, but as having data or information, bits, and I think you're talking about something different when you say knowledge.
We're talking about symbolic knowledge of the type you have, particularly of the type you have about your specialty, but also more generally the common sense, ordinary knowledge of the world. Now, no machine has yet been given the vast amount of common sense, ordinary knowledge of the world that we take for granted, but people are working on that as we speak.